Hello students, and welcome to another video lecture on logic design. In this video we will study the working of a parallel in serial out shift register, better known as PISO. Remember that this shift register takes input in parallel form, but it will give you an output in serial form, that is 1 bit at a time. So this register looks slightly different from the other registers we have studied in previous videos. Don't worry, I will break it down so that you understand. Start of course by drawing 4 flip-flops. Label each flip-flop and mark its inputs and outputs. In this case, the flip-flops are named FF0, FF1, FF2 and FF3. Notice that each flip-flop gets the same clock signal, so draw that. Use proper notation for positive or negative edge triggered flip-flops. Next, remember that this register gets parallel input. So, to give parallel input to each flip-flop, we have to have 4 input lines. In this diagram, the 4 input lines are labeled as B0, B1, B2 and B3. B0 is connected to the first flip-flop input D0. B1 is connected to D1 via an AND gate numbered 2. Similarly, B2 is connected to D2 via an AND gate numbered 4. And finally, B3 is connected to D3 via the AND gate numbered 6. Next, I would like you to notice this combinational circuit. Right here, it is made up of 2 AND gates and 1 OR gate. There are 3 such connections made between each flip-flop. Also notice that the AND gates are numbered. Notice this line called as shift/load. This line is connected via a NOT gate to AND gates numbered 2, 4 and 6. This line is also connected without a NOT gate to the AND gates 1, 3 and 5. Also notice that the output from the first flip-flop, that is Q0, is connected to AND gate numbered 1. The output from the second flip-flop, that is Q1, is connected to the AND gate numbered 3. And output from the third flip-flop, that is Q2, is connected to AND gate numbered 5. Now that you are aware of the connections, let us see how this circuit works. When the shift/load line is high, in other words, it is 1, then the value on this line becomes 0. And the value on this line is 1. So, AND gates 2, 4 and 6 will get input 0, and you know that when input 0 is given to an AND gate, the output is always 0. So, AND gates 2, 4 and 6 are basically disabled. But the AND gates 1, 3 and 5 are enabled since they receive 1 at their inputs. Now since the gates 1, 3 and 5 are enabled, they allow data inputs to appear at the D inputs of the respective flip-flops. So D0 will get its input from B0. D1 will get its input from Q0 via AND gate 1. D2 will get its input from Q1 via AND gate 3, and D3 will get its input from Q2 via AND gate 5. So what this action allows is serial movement of data inside the shift register. When a clock pulse is applied, the data bits will be shifted to the Q output terminals of each flip-flop. The movement of data is towards the right. On the other hand, when the shift/load line is 0 or low, then on this line the value is 1 and on this line the value is 0. So, the gates 1, 3 and 5 will receive 0 at their inputs. In other words, the gates 1, 3 and 5 are disabled, but the gates 2, 4 and 6 will get 1 at their inputs. So, they are basically enabled. So, since these gates are enabled, they will allow the inputs B0, B1, B2 and B3 to arrive at the inputs. So, D0 will get its input directly from B0. D1 will get its input from B1 via AND gate 2. D2 will get its input from B2 via AND gate 4 and D3 will get its input from B3 via AND gate 6. So, what this action allows is parallel entry of data into the register. Given a clock pulse, data will enter into this register in parallel form. This is the working of a parallel in serial out shift register. That's all for now. Connect to the classroom for more videos.